Okay, here we go, section 4.1, ratios and unit rates. Let's take a look at how this is going to go forward from here. Okay, our objectives in this is going to be use ratios to compare two quantities. Okay, find rates, find unit rates, and compare unit rates. All compare unit prices, I'm sorry. Okay, by definition, a ratio is a comparison of two quantities by division. The ratio of A to B can be written as any one of these forms, A to over B, or this A to B or A to B kind of thing. You'll see this a little bit. I'll answer some of the questions in this form, but for our purposes, we're going to be sticking with fractions, as you can see, because we're going to be able to compute these. Remember, fractions is division, and so some of these are going to have to be kind of we're going to be doing division, simplification, addition, subtraction, stuff like that. Okay, so let's look at an example of one. Okay, the floor of a room measures 14 feet long and 10 feet wide. An architect drawing of a scale model of a room needs to determine the ratio of the room's length to its width. Write this ratio as a fraction, okay, in lowest terms. Okay, solution. Notice how it's red here. Measures 14 feet long, 10 feet wide. Okay, length to width. Okay, so notice when you hear the 2, the top, you put the 2, the line, width, bottom. Okay, so our top, the length, okay, is the 14 feet long. Our width, 10 feet. Well, notice here, as it states here, the feet can cancel, and then we can go ahead and reduce, okay, dividing by 2. Here they did prime factorization of both of them, but either way, however you want to do it, just simplify these into the simplest fraction. And notice, though we are dealing with fractions, we need to keep things in fractional form. For example, in one of our examples, we're going to end up with a 1 on the bottom. We would still show this because we're dealing with a ratio. This is a 7 to 5 ratio. And you could also sometimes see that as written as 7 to 5. Okay, so you might see that sometimes. So let's look at an example they have here set up for us. Okay, and they have a ratio here of 2 1/2 to 5 1/2. Well, here notice 2 1/2 to the line, 5 1/2. They've written this as a fraction. Okay, and yeah, it looks like a fraction over a fraction, but still, remember this main fraction bar here is still a division. We're dividing two ratios, and so when we think of it in that form, we can split these back and put them together and write them as a division. But knowing what we know about division of fractions, we don't divide, we multiply by the reciprocal of the second term, in which case this, the 2's would cancel out, leaving us with a ratio of 5 to 11. Okay, so whatever this is a ratio of, we don't know. Okay, we just know this is a ratio of numbers. It could be days, hours, minutes, bags of rice, who knows. Okay, so let's look at another one here. We have 3 days to 1 1/2 days. So let's write it in exactly the way in which we are reading it. We have 3 days, okay, to 1 1/2 days. In fact, let's go and just put the days down so we're kind of being explicit or intentional. I'd like to use that word instead. Well, notice that we can also rewrite this as, notice we've got a fraction here, a mixed number, but we don't have a fraction here, so we could write this as 3 over 1 days. Okay, 2, well, let's turn this into an improper. We got 2 times 1 is 2, plus 1 is 3. So that's 3 over 2 days. Let's grab the other pen here and notice that we can go and cancel the days and realize that now that we're just dividing, we're dividing 3 to 1 divided by 3 to 2. Well, if we rewrite that as, like what we've seen before, 3 over 1 divided by 3 over 2, but knowing what we know about fractions, as I've stated before, we don't divide fractions, we multiply by the reciprocal. So we're going to go ahead and multiply by 2 over 3. That will, notice, reduce out the 3's, and then we are left in our answer, and I'll put this in blue, a 2 to 1 ratio, or a 2 to 1, or 2 to 1. But notice I'm not reducing this down just to 2. I can't do that. Okay, I have to keep this in this form because this is showing a ratio. This is 2 to 1 days. Okay, so basically it's saying 3 days to every 1 1/2 days, and the context of the question depends on what kind of ratio you're talking about. Okay, so let's look at the next example they give us. Okay, we have two lengths of pipe are shown. write the ratio of the length of the long pipe to, there that is right there, to the length of the shorter pipe by comparing the length in meters. Okay, notice length of the longer pipe, we've got 2.4 meters. Okay, so let me get the black pen out here. So we have, let's put that there, we have 2.4 meters, okay, to 1.56 meters. Okay, now what I can do here, if you look very carefully, I've got 2.4 meters and 1.56 meters. Okay, even though the meters canceled out, I've still got a ratio there. Look carefully though and notice, let me kind of get the red pen out here, that I can multiply everything here by 100 and that'll remove these decimals. Okay, so if I multiply everything by 100, just going to put my dot there so we can be intentional. Well, that's going to give me something that looks like this now. Notice I don't have to worry about any more decimals. I've got 240 on the top and I've got 156 on the bottom. Okay, you can do the GCF of this, or you can come in here and just go ahead and divide everything by 12. Okay, and when you do that, when you do 240 divided by 12, you're going to get 20. Okay, and whenever you do 12 by 156, you end up getting 13. So my ratio from length of pipe is 20 to 13. Okay, so let's move along here and continue on with our examples. Okay, find the length of the sides of the triangle are 10 inches, 24 inches, and 26 inches. Here they are. Okay, we've got sides A, B, and C. Find the ratio of the length of the longest side here to the length of the shortest side. Well, that would be the 10. And then we could also find the length of the shortest side to the length of the longest side. So notice how they're wording this very, very carefully. And this one I went ahead and had them, they're going to show us as it is worked out. Okay, so the ratio of the length of the longest side here, to, notice the line, to the length of the shortest side here, 10. So 26 over 10. Notice the inches cancel. We're just left with just numbers now. Okay, we can divide everything by 2 to simplify it, or you could go ahead and do what they did here. They did the prime factorization of it, which the 2's would cancel, and you get a 13 to 5 ratio. Okay, and then find the ratio of the length of the shortest side to the length of the longest side. Notice you're still using the same numbers, but be very intentional with the 2 part of this. Okay, that's what we need to be very careful. Okay, because if you did it this way but you were reading it this way, this would be wrong. Okay, because this is the ratio of the shortest side to the longest side, whereas this is the ratio of the longest side to the shortest side. And it is a big difference depending on how you're going to be talking about it. Okay, so notice the answers in part A and B in example 5 illustrate how the order of the comparison in the ratio is critical. Okay, that's what we just showed. It is dependent because here I want to know the ratio of the length of the longest side, okay, compared to the shortest side, whereas here it's the shortest to the longest. Okay, let's look here. Write the ratio of 30 minutes to 2 hours as a fraction in lowest terms. Okay, notice the smaller units is minutes, because 1 hour equals 60 minutes, we have 2 hours, okay, to 120 minutes. So that means we got to be very careful in how we write this, okay, because if you just do it in 2 hours, okay, 2 minutes to hours, it doesn't make any sense. Let me show you what I mean. Let's write it out as a, you would have something like, say, 30 minutes, oops, made that loop, to 2 hours. Well, we really need something. We don't really have a good ratio here because notice I can't cancel these units right now. So I've either got to do one of two things. Change this minutes into hours, or change the hours into minutes. Okay, which in our case we're going to change them into minutes. So now we have 30 minutes to 120 minutes. Okay, well, I'm writing horrible today. okay, which in this case now will reduce my minutes, and then also makes it to where I can reduce my numbers now, which gives me a very clear definition of what my ratio is. And notice 30 and 20, that's just going to go down to 1/4. So this is going to be a 1:4 ratio of minutes, okay, that I can see. It wouldn't have made sense to have a ratio of minutes to hours, okay? So we have to make sure things are in the same unit. Okay, a bicyclist rides at a steady speed, okay, steady speed over the level ground of 27 miles in 2.25 hours. So here's another little thing. This in, okay, that's the same thing as 2. And notice we're going to be very specific about our order in which we read this. We're doing miles to hours, okay? The rate is indicated by the ratio 27 miles to hours, okay? So notice we're just being very intentional. This is still just going to be miles to, they just said in. To find the unit rate, divide the numerator by the denominator. So we just go ahead and multiply everything here. So we've got 2,700 miles, because what we did, notice what they did here, is they multiplied everything by 100, okay, to go ahead and get everything into the same unit. Okay, and here what they did was, it looks like they just took the, basically factored out the 225, okay, reduced it out. You could have also done this on your calculator. You could have done the 2,700, okay, divided by 225, and you would have got the same answer here. So you can easily do that, but notice there's still a 1 here. We're still keeping this because notice this hour here. You don't have miles, you have hours. So here we know that the speed is 12 miles per hour. We got this unit down to 1 on the bottom, because what does this tell you? If I was trying to buy a car and I said, hey, how fast does that car go? And they said, oh, well, this car goes, or how, you know, I was going to look at gas mileage. Oh, well, this car gets 125 miles to the 10 gallons. That's all fine and dandy, but I don't buy gas by the 10-gallon increments. I buy gas by the gallon. So that's why we need to get things back to a 1. Okay, so in the past, many consumers did not understand the concept of unit price or how to determine such a number. Now most states have a law that grocery stores must display the unit price for goods they sell, so that consumers be fully informed. What this is if you've ever gone to any store, sometimes you'll see something for sale like, say, $5 and it's 12 ounces. Okay, well, if you look at the tag very closely, it's going to tell you how much it costs per ounce. Okay, so let's look at one. Okay, these are unit prices. A 16-ounce jar of grape jam is priced at $3.99, and a 9.5-ounce jar of the same jam is $2.69 or $2.69. I guess I got too used to reading the stuff in the decimal section. So writing this out, we need to be very intentional. Okay, I want the price. Okay, I want to put this very intentionally. Price per ounce. Okay, so the price per ounce, or the price to ounce, notice I'm saying price per ounce, so that's exactly how I'm going to need to write this. I can write this as, well, let's look at the first one. I have a price here of $3.99, okay, per how much? Well, 16 ounces. Okay, on the next one, I have a price of $2.69, well, for how many ounces? 9.5. And I need to find out how much the cost per ounce is, or price per ounce. So I'm just going to use my calculator and go 3.99 divided by 16 and realize, and I'm going to make sure I write this correctly, I have a price of 25 cents per ounce. Okay, that doesn't sound horrible, but let's look at the next one. I've got 2.69 divided by 9.5, and on this one I get a price of roughly 28 cents per ounce. So though this one costs more, I'm getting a better deal because it's costing me less per ounce. Okay, and yeah, most of your grocery stores now are going to show you this kind of stuff, and it is well worth reading. Notice this one is smaller, and it's, you know, you're getting a lot. You're paying less. It is smaller, but sometimes you will see things in the grocery stores that will have the exact same size, and or maybe like this one has like a little less. So I know sometimes you can find pretty good little deals in the stores if you're careful and you're being intentional. Let's continue on. Okay, at the local shop and Save grocery store, bottles of pancake syrup come in 3 different sizes: 36 fluid ounces for $5.29, 24 fluid ounces for $4.69, and 12 fluid ounces for $3.99. Find the price per fluid ounce to the nearest tenth of a cent for each of the bottle and tell which is the best buy. So notice again, we're still doing cost per. Okay, so this is going to be a cost per ounce. So we're going to have this $5.29 all over 36, and then we will have a $4.69 per 24, and then here we're going to have $3.99 per 12, and we can go straight into our calculator and go 5.29 divided by 36, and we get rounded. Okay, we get 15 cents here. Okay, 4.69 divided by 24 for the next one is going to give us 20 cents. Okay, and then for the last one we have 3.99 divided by 12, and that's going to give us 33 cents. Okay, so notice the best one to buy is honestly, it's going to be the biggest. It's the most expensive, but we're paying the least amount per. Okay, so if you'll notice here, this is 2 times as much fluid. Okay, but we're also paying, look at how much less. We're paying almost half less. Okay, it looks like you're paying more because you are in essence, but this is going to last longer and it's cheaper. So let's look at one last thing here. The special term per, as you just heard me say, be aware the term per can be interpreted to mean divided by. For example, cents per ounce means cents divided by ounces. Okay, per, also to, in. Okay, notice cents, like if we looked at this first one, cents per ounce. Okay, dollars per pounds. Okay, but it's also being very intentional where that line is. This divided by, we're having it miles per hours. Okay, so it's miles per hour. Okay, and then miles by gallons. Okay, divided by gallons. Okay, so hopefully that helps out. We'll kind of do some Hawks examples and we'll just kind of keep trudging along.